Children, how are you? Sairam, all of you. Children, in my previous presentation, I have started with the next chapter of your chemistry, that was chemical kinetics. I have told you that in this chapter, we'll be studying about the rate of chemical reaction. Now, in previous video, I have told you the factors on which the rate of chemical reaction depends and what is meant by the rate of chemical reaction. How can we measure it? Now, today we'll be starting with the next topic, that is the law of mass action. Now, this law of mass action will tell you that how can we get the rate law expression. Now, law of mass action, what it is, this you have learned in the previous chapter, in the previous class, in the topic electrochemistry also. In electrochemistry you have already learned this law of mass action. Now what actually it is, see, the law of mass action, it states that at a given temperature the rate of chemical reaction is directly proportional to the molar concentrations of the reactant. That means, suppose we are having a chemical reaction in which reactant A reacts with reactant B and result in the formation of product AB. 2 moles of AB is formed. Now, for such a reaction, according to the law of mass action, see, the rate of chemical reaction is directly proportional to the molar concentration. So, how will we write? We'll say rate is directly proportional to concentration of A into concentration of B. You have to remember that whenever we are talking about the concentration, we have to write down A and B inside a square bracket. This square bracket represents the concentration. So, rate is directly proportional to concentration of A into concentration of B. Now, removing the sign of proportionality, the constant comes, that is this K. So, rate is equals to K into concentration of A into concentration of B. Now, what is K? K is the rate constant. Now, rate constant, how will you define? See, if in the same equation, if the concentration of A and the concentration of B if the concentration of A and concentration of B becomes equals to 1, then what will happen? K will become equals to rate. So, how can we define K? How can we define the rate constant? See, the rate constant may be defined as the rate of reaction when the concentration of each of the reactants is unity. That means when the concentration of all the reactants becomes equals to 1, in that case the rate of reaction, the rate constant is equal to the rate of chemical reaction. Now, rate constant is very important. Many a times in your board exam, some characteristics of rate constants are asked in the form of your multiple choice question also it can be asked. Now, see, next we are proceeding to the characteristics of rate constant K. Now, what it is? It is the measure of rate of reaction. Higher the value of K, faster will be the reaction. Now, this thing you already know that the rate of reaction depends upon it depends upon the concentration. Higher the concentration of reactant, higher will be the rate of reaction. But see, many a times there are reactions in which the concentration does not affect the rate of chemical reaction. Those reactions always proceed with the same speed, whatever the concentration of reactant is. Now, that same speed is given by the rate constant K. Higher the value of K, higher will be the rate of reaction. Lower the value of K, lower will be the rate of reaction. Now, this value of K is different for different reactions. The value of K depends upon the reaction, and different reactions have different values of K. The third point is, at a fixed temperature, the value of K is constant and is characteristic of reaction. However, it changes with the temperature. That means the value of K for a particular temperature, for a particular reaction, K has a fixed value. But if we change the temperature, the value of K for that particular reaction will also change. Fourth point is, it is independent of concentration. That means the value of K does not depend upon the concentration. Whatever be the value of concentration, the value of K will not be affected. So, you have learned about the characteristics of rate constant K. You should also know the units of rate constant K. We will discuss this later on. So, how the question comes on this topic. Many a times it is given to you that a reaction, the same reaction is taking place at two different temperature, whether the values of K will be same or different. So, you have to say if it is taking place at two different temperature, the value of K will be different. Now, if same reaction is there taking place at same temperature, the value of K will be same. Now, many types of multiple choice questions can be made. You can see later on we will discuss. Now, next we have to start with the rate law expression. Now, from where did this rate law expression came? It came from the law of mass action only. It is specific. We are studying about the rate law expression. What actually is rate law expression? It is a mathematical expression that denotes the rate of a reaction in terms of molar concentrations of reactants, with each term raised to the power which may or may not be, you have to remember, I am saying which may or may not be same as the stoichiometric coefficient of the reactant species in a balanced chemical equation. Now, what is rate law expression? It is exactly similar to the expression where I have written for the law of mass action. The only difference is that here the powers of the reactant species are written. Now, in the definition for rate law expression, I have told you the powers may be equal or they may not be equal to the stoichiometric coefficient in the balanced chemical equation. Now children, if suppose sometimes a reaction is given to you and it is told to you that you have to write down the rate law expression for the reaction. At that time, do not hesitate in writing these stoichiometric coefficients as the power. That, for example, I have also taken the reaction in which small a number of moles of reactant A react with a small b number of moles of reactant B and small c number of moles of reactant C. The small a, b, c are the number of moles of reactants A, B and C, and react to give the product. Now, how will I write the rate law expression? Rate law expression will be rate is equals to K into concentration of A raised to power small a, concentration of B raised to power small b, and concentration of C raised to power small c. Here I have written a, small b and small c as the powers of the stoichiometric coefficient, but it is not always the same. In which cases it is not the same, we will discuss later on. Right now, I think you are able to understand what is rate law expression. Rate law expression, it is this mathematical equation. This mathematical equation which denotes the rate of reaction in terms of concentration of reactants, with each concentration term raised to the power equal to the stoichiometric coefficient, which may be equal or may not be equal to the stoichiometric coefficient in the balanced chemical equation. Now, rate law equation, you have to remember, suppose we are having a complex reaction. You know the meaning of complex reaction? Complex reactions are those which do not take place in one single step. In first step, some product is formed. In the second step, that product reacts again with the reactant and result in the formation of another product. And finally, that product react with a previous product and they together form the final product. So what happens? Such reaction which cannot take place in one single step is called a complex reaction. For complex reaction, we see the slowest step of the reaction, the step which is taking place in the slow speed, and that step will be called the rate determining step. Only for that step you can write down this rate law expression. Is it clear? So, for complex reactions, only the slowest step will have the rate law expression. The rest of the steps will not have the rate law expression, and the slowest step will be called the rate determining step. Now, what happens? Why we are saying that the power may be equal or may not be equal to the stoichiometric coefficient? It will be explained with the help of order of reaction. It will become clear if you understand the order of a reaction. Now, what is order of reaction? It is the sum of powers to which the concentration terms are raised in the rate law equation. Rate law equation, I have told you, is that mathematical equation in which the rate is given in terms of concentrations of reactants and products, with each term raised to the power equal to the stoichiometric coefficient. Now that equation will tell you about the order of reaction. In that equation, I have written A raised to power A, B raised to power B and C raised to power C. Now according to this, the sum of powers to which the concentration terms are raised in the rate law equation will give you the order of reaction. So order of this reaction will be equal to the what? Order will be equals to small a plus small b plus small c. So this will give you the order of reaction. Now children, you have to remember previously second order, third order reactions were also there in your course, but now after the new course have been revised, only zero order and first order reactions are there on in your course. So order of reaction, as I told you, is zero order and first order. Now what are zero order reactions? Zero order reactions, what will be the value of A, B and C in case of zero order reaction? What do you think? As I told you, sum of powers to which the concentration terms are raised in the rate law equation will give you the value of your order. Now according to this equation, what should be the value of A, B and C? This small a, small b and small c in order to have a zero order reaction. Yes, it should be 0. For zero order reaction, the value of molar concentrations, not actually molar concentration, the value of powers of stoichiometric coefficients should be 0. For zero order reaction, the small a, small b and small c, all three will be 0. Now that means those reactions in which the rate does not depend upon the concentration of the reactants are called the zero order reaction, and first order reaction will have the sum of these powers to be equal to 1. Clear? So I hope you have understood the law of mass action, the rate law equation and the order of reaction. Now children, as I told you, only zero order and first order reactions are there in your course. So we'll be studying only the zero order and the first order reaction. Now for zero order reaction and first order reaction, you have to calculate the unit of rate constant k. Now the unit of rate constant k you have to calculate. That I'll be teaching you in the next presentation, but you have to do it as a homework by yourself. If it is not if you're not able to understand, we'll do it the next time, but you have to do it as a homework. Now children, it is a request to you all, kindly download the revised syllabus also and study as per the revised syllabus only, because we will also be covering only those topics which are there in the new revised syllabus. Thank you, Sairam.